Right now, dark energy is still tearing the fabric of space apart, and every scientist at NASA, Harvard, and the Webb Space Telescope team has absolutely no way to stop it. It has been doing this for 8 billion years. It is accelerating, getting faster, and what it is building toward is the part they are afraid to say out loud. But here's what nobody is telling you. Dark energy is not a metaphor. It is not a placeholder name for something we vaguely understand. It is a real, measurable force filling every cubic centimeter of the universe, including the space between you and this screen right now. It was discovered in 1998 when two independent teams of astronomers studied dying stars called Type Ia supernovae, explosions so consistent, so reliable that scientists use them as cosmic rulers. They expected those rulers to show a universe slowing down. Gravity was supposed to be winning. Instead, every single ruler said the same impossible thing. The universe was not slowing down, it was speeding up. The expansion was accelerating, and something invisible was doing the pushing. They named it dark energy. Then they admitted they had absolutely no idea what it was. 26 years later, they still don't. Here is what dark energy actually does. Space itself, not objects moving through space, but the fabric of space is stretching. Right now, in every direction simultaneously. Galaxies are not flying apart like shrapnel from an explosion. The space between them is growing. The further apart two galaxies are, the faster that gap widens. At a certain distance, the Hubble horizon galaxies are already moving away from us faster than the speed of light. Not because they break physics, because the space between us is expanding that fast. When the Webb Space Telescope launched in 2021, scientists aimed it at the earliest galaxies, the oldest light in the observable universe. They expected dark energy to behave the way our best models predicted: steady, predictable, constant. What Webb measured instead stopped them cold. The expansion rate did not match the models. The gap between what dark energy should be doing and what it is actually doing has a name. Scientists call it the Hubble tension. And it is getting worse every year. The obvious answer was human error, faulty instruments, miscalibrated stars. The old Hubble Space Telescope had been measuring the universe's expansion for decades. Maybe those numbers were just slightly off. So they handed the problem to Webb: better optics, sharper resolution, a mirror 6 times larger than Hubble's. Webb confirmed Hubble's numbers with agonizing precision. That is the problem. If Webb is right, and it is, then our entire model of how the universe works has a crack running straight through its foundation. The standard cosmological model, the framework every physicist on Earth relies on, assumes dark energy is a constant, a fixed background hum, lambda. The same cosmological constant Einstein once called his greatest blunder. But the data says it is not constant, and that changes everything. Here is what nobody is telling you. Some of the leading models trying to explain the Hubble tension require dark energy to be changing, not constant, evolving, growing stronger over time. And if dark energy is dynamic, if it can increase, then the universe does not drift toward a quiet, cold, empty death over trillions of years. Violently, physicists call it the Big Rip. If dark energy continues to strengthen, the expansion of space eventually overwhelms every force holding matter together. Not just galaxies separating, not just solar systems drifting apart. The tearing becomes so extreme it shreds everything: planets, rocks, molecules, atoms. In the final fraction of a second, space itself tears into disconnected, unreachable pieces. But here's the strange part: it shouldn't be possible at all. In 2024, the Dark Energy Spectroscopic Instrument (DESI) completed the largest three-dimensional map of the universe ever made. 40 million galaxies and quasars, 11 billion years of cosmic history. When scientists ran the full analysis, dark energy did not look like a constant. It looked like something that fluctuated, that shifted, that breathed. A single data point barely visible in the noise, but big enough to make every cosmologist on Earth quietly reconsider the models they have built their careers on. If dark energy is dynamic, we do not live in the universe we thought we did. We live in a universe with an expiration date written in a force we cannot see, cannot touch, and cannot slow down. Everything you know, every star, every planet, every atom exists inside a machine that is accelerating toward its own destruction, driven by something that makes up 68% of all that exists, and that we have never been able to directly detect, approach, or explain from first principles. Einstein called the cosmological constant his greatest blunder because he thought it was unnecessary. He had no idea it would turn out to be real. He had no idea it would turn out to be winning. The greatest minds in physics have spent nearly 3 decades trying to understand what dark energy is. Webb has sharper eyes than anything humans have ever launched into space. It still cannot tell them. What worries them is not that they don't know what dark energy is. What worries them is that the closer they look, the stranger it gets. If it is changing, what is changing it? And what happens when it stops? Tell me in the comments. Do you think we find the answer before the answer finds us?